Hello my friends, in this video we will be taking a look at the autosomal DNA results, predicted phenotype traits, and even GED match. Yes, that's right, GED match will be shown in this video as well. GED match results of a Bronze Age sample from Sardinia, a Nuragic sample from this little island in the Mediterranean Sea. Now, these Bronze Age inhabitants of Sardinia were pre-Indo-European, which means they did not speak Indo-European languages, and they actually did have a little bit of Indo-European ancestry though, like 5 or 10%. I'm not sure the exact quantity of Indo-European ancestry that they had, but they did have a little bit of Indo-European ancestry because they came into Sardinia from north of Italy. There is strong theories. There is strong evidence for theories that suggest that they have some common heritage with the Etruscans, Nuragic people of Sardinia, and there is also genetics-wise there is strong evidence for that as well because they have a little bit of steppe ancestry. Now, as you can see with G25, this sample is closest to Sardinians, modern inhabitants of Sardinia, than Basques, but Basques come at a further distance. Basques are further from this sample, and it can be modeled as a mixture of basically 100% Sardinian. So it is 100% Sardinian in its admixture. It doesn't really get modeled as anything plus anything. It's just very, very pure. But if we look at its results with GED match, namely the MDLP World K11 calculator, which I use, which is a very good calculator for determining like step admixture and Europeans and stuff like that. I like this calculator a lot. Unfortunately, some categories, some groups on this calculator are misnamed. For example, WHG here does not actually represent Western hunter-gatherers. It represents all European hunter-gatherers, which includes Western and Eastern hunter-gatherers. And EHG here actually does not represent Eastern hunter-gatherers. It represents Caucasian hunter-gatherers. So the fact that this Sardinian is scoring 3.9, so 4% Caucasian hunter-gatherer admixture, it is evident. It is evidence of step admixture in the sample, and 19% European hunter-gatherer admixture. Of course, a portion of this is from just farmer admixture because European farmers had a very large chunk of European hunter-gatherer admixture to begin with, but a, a small portion of this ancestry is also from the Indo-Europeans as well. So we have to assume that probably around 4% of the WHG is from the Indo-Europeans, plus 4% of the EHG is from the Indo-Europeans. So altogether around 8%. My estimate is around 8% of ancestry from the Indo-Europeans is in this sample. So this sample is around 8% step in total, which is quite large for somebody who is not Indo-European whatsoever. So this really goes to show you how samples in Europe, all these European samples from Europe, despite even if they are not Indo-European whatsoever, still have steppe ancestry. Steppe ancestry is just so pervasive; it's everywhere. Even if these people do not speak steppe languages, have nothing to do with steppe, even if they are on an island in the Mediterranean, as far as you can get from the steppe, they still have plenty of steppe admixture. I think it's really fascinating. But anyway, we're gonna go and explore the autosomal results of this individual. We're gonna start with Nashakot results. And for the Nashakot results, it looks like this sample has got brown eye color at 85.7% odds. Then there is 10.4% odds for hazel eyes, and there is 3.2% odds for dark brown eyes. So most likely the sample has brown eye color. And most likely the sample has dark brown hair, although there is also a 31.4% odds for black hair. So most likely the sample has brown eyes and dark brown hair, and the sample also most likely has light brown or olive or Mediterranean skin. It's kind of evenly split between light brown and olive skin for skin tone, but light brown skin is slightly higher at 54%, whereas olive skin is slightly lower at 45%. So most likely the sample actually has light brown skin. And for hair texture, it is scoring most likely wavy, followed by that is curly, so most likely wavy hair texture. For nose shape, it is scoring most likely Greek shaped nose, so most likely a rather long and aquiline shaped nose, which is kind of typical for Sardinians. So overall, it's looking very Mediterranean so far from what I'm seeing. Greek shaped nose, wavy hair, light brown or olive skin, dark brown hair, and brown eyes. Looks very Mediterranean to me. Now, it's got two light color variants in all these variations of HERC2, which is very, very interesting. With the genotype like this, I'm expecting snipper 3 to say something lighter than brown, to say green or hazel, for example. And heterozygous genotype in these variations of BH2. That's very, very interesting. No blue haplotype 3, but heterozygous in these variations of BH2. So, okay, with snipper 3 and has blue haplotype 1. So with snipper 3, this is going to say green or hazel for sure. Snipper 3 is going to say green or hazel. But really, if you look at this, for example, um, what else? What else is there to look at? So if you look at this, or if you look at this, especially this, yeah. So it's definitely going to be brown, especially if you consider these genotypes. But Snipper 3 doesn't really value these important genotypes like SLC genotypes in SLC 45A2 in the context of eye color prediction. Snipper 3 doesn't value them that much. So with Snipper 3, this is going to be green or hazel for sure. But really, in reality, it's not. In reality, it's brown. Brown eyes are the most likely eye color for this sample. But I'm just going to show you the flaws in Snipper 3 in this video in their system for classification of eye color. And no light color variance in MC1R. So it's gonna be green or hazel with Snipper 3, but it is not correct. It is not the correct classification. Let's look at it. Yeah, there you go. So it says this profile should be green or hazel, but it's not correct. It is completely incorrect. That's because Snipper 3 does not value the genotypes in SLC45A2 as much as they should for the classification of eye color. That's the only reason that this profile scores green or hazel. It should not score green or hazel. It should score brown. But there you go. All right, let's close this and let's look at the phenotype oracle. So for the phenotype oracle, this sample is closest to this phenotype, which is a Mediterranean phenotype. Followed by that, this sample is second closest to this phenotype, which is another Mediterranean phenotype. All these phenotypes look very Sardinian to me, both of them. Although this one I think is called pointed. I think this one is called pointed, which has to do with Greece, right? Greeks, pointed is like area in Turkey that used to be inhabited by Greeks. So this is like a Greek from Turkey phenotype or whatever. But it looks Sardinian to me. This definitely looks very Sardinian to me as well, and this also looks very Sardinian to me. So all these phenotypes look very Sardinian to me. And for the mixture of phenotypes, the closest mixture actually is kind of funny. So it's a mixture of this exotic-looking whatever plus whatever this is, berberid. Second closest mixture is this exotic-looking whatever plus. I think the closest phenotypes closest to you, the three closest, are more accurate actually than the mixtures in this case, because the mixtures look kind of weird. Yeah, the mixtures are kind of weird looking. But I guess if you look at the values, if you look at the because every phenotype that I've got in my hash map has a certain set of values attached to them, representing their hair texture, their skin color, eye color, hair color, their facial morphology values, such as like their nose shape, their ethnicity, or what ethnicity they represent. So like and the ethnicity, it's not the ethnic calculator, it's not the ethnicity calculator that affects that, it's the facial morphology oracle, it's this that affects that. So I guess if you average out this plus this and this plus this and this plus this, you get something that resembles these three, which is kind of crazy to imagine, but I guess that's how it works. All right, let's close that. Let's look at the biomarkers panel. And for the biomarkers panel, he seems to be scoring. And by the way, I never mentioned his haplogroup. His Y-DNA is R1b. I was not able to find out his mitochondrial haplogroup because the file is kind of icky. It's not a very good file. I wasn't able to run it through the James Lick mitochondrial haplogroup predictor, and I don't have mitochondrial haplogroup predictor on my trait predictor, so I can't really determine that. The mitochondrial DNA any other way. Actually, there is a way I could determine the mitochondrial lineage, but I didn't do it, so I guess there is no mitochondrial lineage in this video. Maybe I'll post it in the comments later. But anyway, he's got lower levels of vitamin D. Yeah, I think I'll post it in the comments. He's got higher levels of LDL cholesterol. He's got higher levels of HDL cholesterol. So higher levels of HDL cholesterol is good, but higher levels of LDL cholesterol is bad for sure. Although it's still kind of in the general good level, general good range. It's not so far out from the normal range. Like it's still okay. For glucose, he's got lower level of glucose, which is definitely good. He's got a higher level of hemoglobin, which is okay. Generally, higher level of hemoglobin is not so good, but it's okay. It's still kind of in a generally good range. And he's got higher level of blood pressure. Still, higher blood pressure is kind of bad, but in this case, it's okay because it's still in a generally good range. He's got higher level of iron in the blood, which is very interesting why he scores that. There might be hemochromatosis variants. In this case, there might not be. I'm not even sure if that's higher than average. It looks like it's a little bit higher than average. So we'll find out after we look at through the file if he does have hemochromatosis variants or not. He's got slightly lower levels of sex hormone binding globulin. He's got slightly lower levels of red blood cell count in blood, and he's got slightly higher expected telomere length, so longer predicted lifespan, and definitely shorter expected height for height. So predisposed to being shorter than average. Very, very interesting. I'm not sure what the average height of Sardinians is, but this sample is predisposed to be a little bit shorter, 1 centimeter shorter than average. All right, let's look at the polygenic risk scores and find out what genetic predispositions are for this sample. We are only going to look at genetic predispositions that are very extreme, so stuff that is very below 1 or above 1. So very much lower odds of kidney stones, very much lower odds of hemoglobin E disease, lower odds of migraine, average odds of lupus, lower odds of gout, average odds of thyroid cancer. We have to talk about thyroid cancer because there is a panel for it. Lower odds of eczema, very high odds for exfoliation glaucoma, and very, very high odds for open angle glaucoma. That's very interesting. Let's look up open angle glaucoma. I might be able to find something in this file for it. Yes, I did find something. So I found this genotype that leads to primary open angle glaucoma. Very, very interesting. And that actually goes in the rare disease and traits panel. So this sample has a genotype that corresponds to a very high risk for open angle glaucoma. So this might go in the thumbnail of the video actually because it's such a rare condition. So that's very interesting. This sample is definitely predisposed to open angle glaucoma. All right. Higher odds for PCOS, which is a good thing that this sample is not a female, so it doesn't have to worry about that too much. Average odds for cataracts, very low odds for age-related macular degeneration, low odds for rheumatoid arthritis, average odds for Tourette's, higher odds for epilepsy, average odds for asthma, lower odds for leukemia, above averages for vitiligo, above averages for myopia, average odds for corneal astigmatism, above averages for primary biliary cirrhosis, lower than the average odds for stroke, lower than the average odds for male pattern hair loss, which is very, very surprising because this sample is actually a Mediterranean, and Mediterraneans are stereotyped. There's a stereotype that Mediterraneans are the ones who lose their hair the earliest. Mediterraneans have the thickest beards. Mediterraneans have the highest DHT levels. Mediterraneans are the ones who lose their hair the earliest. So it's surprising that this sample is at the heart of the Mediterranean, and he's the one that has such a low score for male pattern hair loss. So definitely quite protected from male pattern hair loss. We will be exploring that in detail a little bit later. What contributed to such a low score for male pattern hair loss? He's got low score for atrial fibrillation, low score for deep vein thrombosis, average score for cardiovascular issues. So for cardiovascular issues panel, he's got average score for that. Average score for ADHD, average score for depression, slightly above average score for bipolar type 1, higher score for schizophrenia, higher than average score for schizophrenia, below average score for type 2 diabetes, and above average score for type 1 diabetes, higher than average score for Alzheimer's, quite high score for Alzheimer's. This might be the highest thing he scored for, aside from the open angle glaucoma, and below average score for multiple sclerosis. All right. So the one thing we have to remember about this file is the open angle glaucoma. That's the thing that really strikes. That's the really striking thing about the sample. It's the open angle glaucoma. He's got 3 risk variants for breast cancer out of 14. All right, that's kind of typical. Above averages for prostate cancer, above averages odds for brain cancer, but that's kind of typical as well. 15 risk variants for testicular cancer out of 18. That's really high. And he's got all the risk variants in Kittle G, so he's quite cooked when it comes to testicular cancer risk variants in Kittle G. But that's typical for Europeans, so I guess nothing too surprising here as well. 1 risk variance for celiac disease out of 10, which is typical as well. Nothing found for GSS. 1 for Crohn's, but this is not marked as important, so it's not that big of a deal. And do we see any other uncommon risk variants anywhere else? No, we don't see any other uncommon risk variants. But we do see 9 risk variants for allergies out of 16 total, which is really high. So he's definitely quite predisposed to allergies. But nothing in this sample is quite as striking as the result for open angle glaucoma. All right, let's close that. Actually, let's go over the rare traits and diseases panel and see if there's anything else here that's concerning. He's a carrier of a risk allele for neural tube defects and spina bifida. And that's it. And he's got higher odds of esophilic esophagitis, but that's it. That's pretty much it. And there is no other rare diseases and traits that he has. That's pretty much all there is to it. All right. Okay. Let's go through the monogenic traits and find out if there's anything else. I wanted to find out if he does have hemochromatosis or not, so we're gonna get to that a little bit in a couple seconds. He's got warrior phenotype for warrior versus warrior, so he's definitely quite a warrior. And of course, that takes into account the genotypes in COMT, MAOA, and MAOB. In this case, there is actually a genotype in MAOA as well, so it's MAOA, MAOB, and COMT. He's got this genotype in COMT, which is a warrior genotype. He's got this genotype, which also is a warrior genotype. I'm pretty sure most of the genotypes he has are warrior genotypes, but some of them are probably warrior as well. All of them are homozygous genotypes, so there is probably one that's like a warrior genotype here, but I don't remember which one it is. Probably it's this one. This one is probably a warrior genotype. I don't know that for sure. I'd have to look that up in my code to know for sure. But he is scoring 47% odds for warrior and only 15 for warrior, so he's definitely much more of a warrior. Warrior essentially means that you have higher activity of the COMT, MAOA, and MAOB enzymes, and lower dopamine levels because of that, because these enzymes eat up your dopamine, and because of that you got higher stress resiliency when natural dopamine production is higher. And there you go. For the dopamine receptor side panel, he's scoring intermediate number of dopamine D2 receptors. So he's got intermediate predisposition to such conditions as schizophrenia and bipolar. For 5-HT and serotonin, he's got the predisposition to intermediate levels of 5-HT and serotonin. So intermediate predisposition to such conditions as anxiety and depression. He's a carrier of a rare allele associated with longer sleep duration, which is very interesting. I don't see that very often. Okay. He's got a predisposition to higher odds of autism, which is very, very interesting. And he's got a predisposition to intermediate odds of lactose intolerance. That's interesting. So out of these 3 variations, he does not carry. He carries 1 allele for lactose persistence. And it's not exclusive to Europeans. It is not the allele that came about in the Bronze Age and started spreading in Europe, and now most Europeans have it, and it's the one allele that most studies use to discern lactose persistence in Europe. No, this is like the alternative allele that is responsible for lactose persistence worldwide in most populations in the world. So this is not the European lactose persistence mutation, right? This is the worldwide lactose persistence mutation that he carries. So, being heterozygous here, he's scoring intermediate odds of lactose persistence. Keep that in mind. And he does not carry the European mutation for lactose persistence. Because why would he? He's a Bronze Age sample from. Let's look at the time period. He's a 11th century before the Common Era sample from Sardinia, and this mutation came about in the Iron Age. It really started to take off in the Iron Age, and only pretty much in Northern Europe. So why would somebody from the Bronze Age in Sardinia have it? For empathy and OXTR, he's scoring average or lower level of empathy, which is very interesting. For these forests and peace, based on these forests and peace, he's scoring average or lower level of empathy. Okay, hemochromatosis, nothing relevant was found. Okay, so his score for hemochromatosis was based on other genotypes that have to do with hemochromatosis, not on the HFE variants. There's actually some other genes that go into that have a role in determining the score for iron on biomarkers panel besides the ones in HFE. Yes, there's other variations that contribute to the iron score, but HFE genes have the largest contribution. So you can generally determine whether or not you have hemochromatosis variants by the score. If it's really, really high, you probably have hemochromatosis variants, but you cannot always be sure. And then in this case, as you can see, he does not have any genotypes in his file for HFE, but he still scored slightly higher than average. So I wasn't sure if he had hemochromatosis variants in the file or not, and it looks like he does not. It's simply not in the file. For Alzheimer's, he was scoring 2 times the average odds for Alzheimer's, but he does not have any risk variance for Alzheimer's in APOE. In fact, APOE is not even in the file, so we can't really know that for sure. For multiple sclerosis, no risk variance for multiple sclerosis in the HLA gene, really good to see that. And for cardiovascular issues panel, he's got intermediate odds of cardiovascular issues, really good to see that. I'm getting these confused. Don't confuse the cardiovascular disease panel here with the cardiovascular issues panel on the polygenic risk scores, because that one on the polygenic risk scores is a combinational panel of the cardiovascular disease panel and the homocysteine panel on the bottom of the page. Okay, so he does actually have some risk variance in HLA gene for vitiligo, which is very, very interesting. I will be very curious to find out what he scores for the HLA gene panel. And he does not have any non-European alleles in EDAR. Okay. And he's got lower odds of missing teeth, and he's got larger nose size, he's got more upturned nose, and he's got longer midface length. Okay. Does not have micropenis. No variance for micropenis. Really good to see that. Sometimes you find some samples who do have micropenis, but of course it's because of genotyping errors. It is not because of them actually carrying the variants for micropenis. That would be ridiculous. He's got no variants for increased pain sensitivity, and he does not have photic sneeze reflex. Okay. Okay, he's got not a carrier of cutaneous albinism type 1b or type 2, so he's not albino. And for the MCHFR panel, we see really bad results here. So this genotype in MCHFR would probably really ruin the homocysteine panel quite a lot. So this genotype in MCHFR has a big contribution to the homocysteine panel, and 10 to 20% efficiency processing folic acid and high homocysteine levels. This plays a big contribution to the homocysteine panel, and it's a very negative contribution. However, there's also this genotype right here in MCHFR, which does the opposite, which is a very positive contribution to the homocysteine panel. So I think overall it probably wouldn't be that bad, just considering these two together. But if it was just this one genotype, it would probably be a lot worse. For cancers panel, he's scoring lower odds of epithelial cancers. All right, he was scoring above average for glioma and for prostate, but for epithelial cancers, he still scores lower odds of epithelial cancers. That takes into account genotypes in 8q24. 8q24 is a region of your on your 8th chromosome that has to do with that's really implicated in development of various epithelial cancers. We can check genotypes here, and it looks like he's got quite a lot of genotypes here, but overall they're quite good. So, for example, this is a good genotype. 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 So mostly good genotypes here. And by the way, what's interesting is they're all homozygous. All the genotypes are homozygous. All right. Okay, we went over the rare disease and traits panel, and for androgen receptor gene panel, he's got AA genotype in this variation, which means he won't go bald. Now that is a crazy genotype for somebody who's a European from Sardinia. That's actually a completely crazy genotype for a Sardinian individual. Now I'll explain to you why. Let me show to you why this is such a crazy genotype for a Sardinian individual. Um, because let's open DBSNP, and I'm gonna show you the frequency of the A allele in this variation, right? For Europeans, right? For I think Ashkenazi Jewish is the best reference for Europeans, Europeans from the Mediterranean area, because Ashkenazi Jewish are very similar to Mediterraneans. So the frequency of the A allele is like 11%. That means to have AA genotype, that's 1% frequency. So around 1% of Mediterraneans have the same type of genotype as this individual. That's how rare this type of genotype in the AR gene here is. But if you look at and then there's parent-child cohort, which is like Western Europeans. It's a little bit more common. It's 13% for A allele, which means the frequency of the AA genotype, which would be the AA here, which would be 13% times 13%. That would be like 13 times 13. How much is that? That's I think that's like point. I think that's like 1.6% or something. So 1.6% likelihood of having AA genotypes such as this individual for Northwestern Europeans is really low as well. But it's not as low as if you look at Mediterraneans specifically. Mediterraneans such as Ashkenazi Jews are a good proxy for Mediterraneans in general, I think. But um, if you look at Africans, for Africans, the A allele is very common. It's very frequent. Most Africans have the A allele. Africans are quite protected from losing their hair and going bald in this AR gene. Africans are chilling. They are definitely very protected from losing their hair. So this sample has this African allele, this African genotype that protects them from going bald, and it's very uncommon for Europeans, as I've shown you. It's like 1% of Europeans have this type of genotype, and something like most of Africans have this type of genotype, and he's got this genotype that protects him from going bald. So it's very interesting. Right, for Kahneman syndrome, he's got no risk variance for that. For HIV and AIDS panel, he's got the protective variant NHLAC, which leads to a 60% reduction in HIV viral load, which is really good to see. And for HLA gene panel, he actually scores lower odds of autoimmune disease. So despite the risk variance in HLA gene for the vitiligo, and despite that, he still scores lower odds of autoimmune disease, which is really interesting. Well, let's check the HLA genotypes. You might get a clue why that is. So we see good genotypes in HLA-A, we see good genotypes in HLA-B, we see good genotypes in HLA-C, so that makes sense. Yeah, a lot of really good genotypes in HLA-A, B, C. We see the good genotypes in HLA-D, but this is bad in HLA-D. This leads to higher odds of lupus. This is good. This is bad. Okay, this is bad for vitiligo. This is good. This is good. This is good. This leads to 7-fold decrease in type 1 diabetes. This is good. This is good. This is good. This is good. And this is bad. So mostly really good genotypes actually. So the important stuff is really good here. All the important stuff is good. So because of that, the sample is scoring quite good for HLA gene panel. And for a CBS panel and homocystinuria, the sample is scoring actually intermediate homocysteine levels. So despite the MTHFR genotype where they have like 10 to 20% efficiency in processing folic acid, despite that, they are still scoring intermediate and not elevated homocysteine levels. Despite that, because well, they have the other genotype in MTHFR, which is also really important, which was good, and because in the CBS gene panel they have genotypes that lead to decreased homocysteine levels. So I guess that sort of equalized the result a little bit and negated the effect of the really unhealthy MTHFR genotype. Okay, for muscular dystrophy myopathy, he's got no risk variance for that, no risk variance for ADL either, and no risk variance for color blindness and OPN1SW. He's got lower or intermediate odds of obesity based on 1, 2, 3, 4, 5, 6 SNPs, He's got average ulcer syncope based on 3 SNPs. Okay, what about... He's got 2 copies of the quote-unquote hunter-gatherer CLT-CL1 gene variant, reduced ability to process carbs and sugars. Essentially, this gene variant has to do with your ability to process carbohydrates and sugars in your diet. And they named it hunter-gatherer versus farmer because they noticed that the variant that leads to a increased ability to process carbohydrates and sugars would probably be advantageous to people who live a farming lifestyle and who who consume more carbohydrates and sugars, right? But I'm not sure about the ethnic implications of this variant, whether the farmer variant is more common in farmer communities. I'm not sure. I don't really know about the ethnic distribution of this variant exactly. I never looked that up. But it is funny that this Sardinian, who Sardinians historically are the most farmer in Europe. They were the first people to start farming in Europe. They have the largest amount of farmer ancestry, European farmer ancestry in Europe. It is very ironic that this Sardinian individual is scoring 2 copies of the hunter-gatherer CLT-CL1 gene variant for sure. I personally find that quite ironic, but I don't know. Maybe in the comments you can let me know. Maybe I'm missing something here. But I'm gonna finish this video with the blood group panel. And it looks like with the blood group panel, he is scoring blood type A at 92% likelihood. So most common blood type is type O, but I'm frequently seeing blood types besides type O in these videos. In fact, I think I'm seeing about as many type O's as I'm seeing types that are not O, like A or B or AB or something else. So if I had to estimate the frequency of blood types I'm seeing in my videos, maybe it was like blood type O is like 40% and everything else is like 60%. So I guess blood type O being most frequent doesn't mean that every video is type O, which I guess it adds a little bit of diversity. I like seeing blood types that are not type O as well. It's kind of interesting to find people with blood types that are divergent from the typical type O or any whatever. So anyway, this sample has blood type A. Definitely, it's a very definite prediction. There is no confusion here. It's very easy to predict in this case. Definitely blood type A. Now, thanks for watching my video. Make sure you leave a like and subscribe. Make sure you check out the description. The description has a lot of very cool stuff. And leave a like and subscribe if you enjoyed it. And thanks for watching. Goodbye.